is equal to the absolute value of x minus 3 plus 4. First of all, you have to know that an absolute value function is a v. You need to know that. You need to know that right off. Does everybody see the absolute value sign? You should say, oh yeah, that's a sharp v. Okay. So the first thing we do is determine our shift left and right, up and down. Shifting works the same for all functions. Anything added with x in parentheses or grouped with x is your shift left and right? Everybody? And don't we go opposite? So we're going to be going right 3. That is opposite of negative 3. Does everybody understand why it's right 3? So we're going right 3. Anything added to your function on the outside of the function is your shift up and down, and your sign stays the same. So we're going up 4. So that's where we're going to start, right 3 up 4. So I'm going right 3 up 4. There's the vertex, they call it, the lowest or highest point. Now this is not a quadratic. Quadratics are nice round U's. This is a v. It's an absolute value function. So absolute value functions have slopes. So isn't this a value in front a 1?
Yeah.
So our slope is 1 over 1. That's rise over run, right, people? So up 1 over 1. So from there we're going up 1 over 1. It's a positive up 1 over 1, and we're going to do that on both sides because this is a sharp v. You've got to know what the sharp v. I have people drawing lines for absolute value functions. I'm not quite sure why. Okay. So that's what it simply says graph. So you would click, you would do exactly what I just did. It's going to be computer generated. So you would click and you'd start your point right there, boom, and then you'd click on a few other points on that line. Does everybody understand that? We're all good with absolute value functions. So if it would have been a negative in front, it reflects it upside down. We would have gone down 1 over 1, down 1 over 1, sharp V's. Okay, so number 2. I'll let you get the problem down and then we'll go. So it's asking us once again to graph 2y minus 9 is equal to negative 3x squared minus 6x. So first of all, guys, to graph something, it needs to be in the form y equals the function. Do you all remember that? For any function, no matter what, it needs to be y equals. So we need to get our y alone. So what's our first step? Good. Add 9 to both sides. So we have 2y is equal to negative 3x squared minus 6x plus 9. We're trying to get it in y equals form. That's graphing form, guys. So we'll divide both sides by 2, both sides of the equation by 2. And now we've got to, our y is alone. We're going to divide each of those things by 2. So isn't that going to be negative 3 halves x squared? Yeah? And then negative 6 divided by 2 is?
Negative 3.
Negative 3x. Are we all following that? I'm dividing each term by 2. 9 divided by 2. So I'm going to just say plus 9 halves. Now, to graph it, you could use your calculator, and that's what I would suggest, because this is a pretty messy one. However, it should be easy. So let's all type this into our calculator. Then we'll go to the table. We'll plot some points here. Okay, so get your calculator, and let's get some x, y points. So type it in. So we know it's quadratic, so we do know it's a U shape, and because of the negative in front, of x squared, we know it's an upside down parabola. Okay, let's get some actual points. So second table. So I'm gonna just use some easy points here. So if you look, you can scroll up or down. We have negative 4, negative 7.5. We have negative 3, 0. We have negative 1, 6. And 0, 4.5. I'm going to make sure I get as many XY points as I can, just to be exact here. So let's go 1, 0. We'll see if that's enough. So I'm going to plot that so far. So we're going negative 4 up, down negative 7.5. So down negative 7.5. Just plotted that point. We're going negative 3 up 0. So negative 3 up 0. We're going negative 1 up 6. So negative 1 up to 6. Sweet. Over 0 up 4.5. So 4.5. Over 1 up 0. Okay, awesome. That's probably enough. Do you see how it's an upside down? And then you can hit graph. So you know it looks like an upside down U. So now I'm going to go ahead and draw that in, connecting those points. Questions on that? Yes. You must have forgot the negative in front here. I just typed it in negative 3 divided by 2x squared. Make sure you didn't type in minus. Minus, because a lot of people on accident will type in minus 3 divided by 2x squared. Make sure you put it in a negative sign. Do we have any questions on that? And then I can come check your calculator, but it's all in typing it in, right? Were other people able to get it on their calculator? Okay. Okay, so I'll come make sure that your calculator's good in just a second if we need to do that. Okay, next problem here. Okay, it says, which value of x is a possible solution of this equation? So we've done this many times. So first of all, when it says, which value of x is a possible solution, guys, what is it asking me to do? Solve. Awesome. Way to go. It's solve. Now, remember, if we're missing, if it's quadratic, so we know we're going to have two solutions here. And then it's quadratic, and then notice, guys, even though it looks like there's three terms, there's not. Aren't we missing? Quadratics have the form ax squared plus bx plus c if they're in standard form. Aren't we missing a bx? There's no x here, right? So solving for missing bx are the easiest ones. We're going to isolate x squared. So we'll add 2 to both sides. So we have 3x squared is equal to 98, right, people? And then we'll go ahead and divide both sides by 3 to get x squared alone. Okay. So this one's a pretty advanced one because you're going to have to think. So we have x squared is equal to, does that simplify? Type it in to your calculator. No. So we change it back to a fraction. You're going to have to think on an advanced level. It didn't say round to the nearest decimal, so we were going to want an exact answer. So we're going to leave it as x squared is equal to 98 over 3. So from there, now we're going to solve for x. So we'll square root both sides of the equation, right? So root cancels out with power. So we have x is equal to plus and minus the square root of 98 over 3. Now remember, this is not considered simplified. Because remember, isn't this x is equal to plus and minus the square root of 98 over the square root of 3? Yeah? Okay, can we have a radical in the bottom of a fraction? No, we've got to rationalize the denominator. So we're going to go ahead and say, okay, so I need to multiply by the square root of 3 over the square root of 3. That's just a fancy 1. A fancy 1 I'm choosing so that the bottom's radical will not be there anymore. So we have x is equal to plus and minus. Now remember, you multiply fractions straight across. So the square root, they're both square roots. So we can multiply those together. 98 times 3. So on top we have the square root of 294. Is everybody following me? And then on bottom we have the square root of 9. So I'm showing all my work here. So really we have x is equal to plus and minus the square root of 294 divided by what's the square root of 9? 3. Does everybody see how we took care of the radical on bottom? Okay. So then from there, we would just need to make sure our final last step, and I know you guys can do it. I know this seems a little bit hard, but I know you guys can remember this and do this. So you'd say to yourself, I need to see if this radical breaks down. So you could try it in your calculator, but it's going to be a decimal. So you have to go off to the side and say, okay, I know that if it's a decimal, I'll see if it breaks down by hand to give the exact answer. If it said decimal, it wouldn't matter. So let's do that. What are some factors? 294, let's go. You said, 6 and 49, and there's probably some others. I heard somebody say 6, I swear. You said, okay, awesome. So you said 6 times 49, great. 49 breaks down into 7 times 7, right? 6 breaks down into 3 times 2. Now don't double dip. There's some double dippers in this class, and it's gross. The 6 isn't there anymore, the 49's not there anymore. We broke those down. This isn't there anymore, we broke it down. So now because of the square root, we're pulling out groups of 2. Isn't there 2 7s? This has got to stay, this has got to stay, right? So we have 7 square roots of 6. Don't we multiply those back together? Okay, we're almost done. We have x is equal to plus and minus 7 square root of 6. This simplified to be 7 square root of 6 all over 3. Now my question for you is, can you take this 6 under the square root and divide it with 3?
No.
Wrong. You cannot. Good. Not wrong. Right? You cannot. I was saying wrong. That would be wrong if I did that. Didn't mean to scare you then. You were right. There's our answer. Ding, 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 ding. And it did say what value of x is a solution, so both of those are solutions. That was a pretty advanced one. I know you can do it, though. I really do. Questions? Okay. All right. Maybe we should get to the lesson for today. I think we're going to stop there and get to the lesson for today. Yeah. Okay, so 9-3, let's get going. Today's lesson's important. That's why we're doing it. You'll see it again next year, so don't forget it. You'll see it on your test this year. So let's go through this here. So today we're doing 9-3. We're going to be graphing inequalities with 2 variables. Now, we were solving inequalities the other day with 1 variable. Today we're going to be graphing, and we actually, the day after, we graphed inequalities. So today's actually going to probably seem really easy for you. Because remember when we were we were solving systems of inequalities, and you solve them by graphing. Because remember, there's multiple solutions for an inequality. So today's going to be pretty easy for you. Okay, so remember that we have learned how to solve an inequality, and this has 1 variable. Do you guys look at this problem? Does everybody see how there's just an x? So this one's pretty easy to solve. We're going to solve it like this is an equal sign. Just remember, the only catch is if you multiply or divide by a negative, you got to change the sign of the inequality. Okay, so let's bring our x's together. So we'd subtract x from both sides. So we have x minus 3 is greater than 4. X minus 3 is greater than 4, so we'd add 3 to both sides, right? So we'd add 3 to both sides. So we have x is greater than 7, right? So now we'll graph that answer. There's our solution. There's many answers here. That's why we graph it on a number line. Any x value that's greater than 7 will be a solution. So we go to our number line. Looks like I need to put in some tick marks. 0, 1, 2, 3, 4, 5, 6, 7. That's 7. So x value is greater than 7, not including 7, would be like that. That would be how we would graph our solution. Is everybody comfortable with that? X value is greater than 7. Isn't 8 greater than 7, 9, 10, 11, 12, continuing to infinity? Yeah. Approaching infinity. Awesome. Questions on that? Okay. So now understand though, there's a difference between solving and there was only 1 variable. Today we're going to be graphing inequalities with 2 variables. And when we graph it, it's going to be showing all the solutions. Just like when we graph here, we're showing the solutions. Okay, so here we go. We're just going to go by example. Here's my first example. Honestly, I think you'll be okay just watching, not taking notes from here on out. Because you'll be able to practice this on your own. And you guys know how to graph a line. You guys know pretty much what we're doing here. So watch, okay? So it says graph the inequality. So first of all, you got to say, what kind of graph is this? Isn't this a line? Yes, right? So we're going to graph the line. So our y-intercept is -2, and then we have a slope of 1. So we go up 1 over 1. Now I'm just going to do dots for right now. I draw in my line. Okay. Now my question for you is it including the line? No, it's y values greater than, but not including that line. So that means not including anything on that line. So we've got to draw a dotted line. So we draw our dotted line because points on the line are not a solution because it's dotted. Does everybody understand that? So points that fall on this dotted line are not a solution. And now we've got to shade it correctly. If y values greater than, aren't y values larger than? Wouldn't that be above the line? Yeah? Y value larger than the line. Wouldn't that be above? Does everybody make sense? People say, they try to memorize things, and I don't like it. They say, okay, so if it's this way, you shade this way. And I'm like, no, think about it. Y value is greater than the line. That would be these y values above the line, because those are y values greater than the line. So our answer would look like this, with all of this shaded. So I want you to understand a couple things. Anything that falls in this shaded region, any xy point, if we plugged it in right here, it would be a true statement. As long as it falls within this shaded region. So look, everybody, just so you understand what you're finding. So I'm just going to give you some examples. Isn't over 0 up 2 a solution? So let's see, 0 up 2. If we plug that in, that's xy. So we have 2 is greater than 0 minus 2. Isn't that true? 2 is greater than -2. Yeah, so any point that falls in this shaded region will make this a true statement. Do you guys all understand what we're finding? Awesome. Okay, next one, graph this inequality. Y value is less than negative x plus 3. So our y-intercept is 3. We're graphing a line again. It's not always going to be a line, though. It's the same idea, though. So we're going up 3, and then we have a slope of negative 1. Now, some people just simply are not very good at graphing lines. Isn't this negative 1 over 1? It's rise over run. The run is always to the right. So, down 1 over 1, down 1 over 1, down 1 over 1. And continuing that. Does it include the line? No, right? Y values less than, not including the line. So I'm going to draw in a dotted line. And y values less than. Y values less than that would be below the line. Are we all good? We all good with this, with lines? If it would have been including, it would have been a solid line. Okay, I won't graph this one. But let's just look at it. Can we graph it as it is right here? No, so let's just quickly get it in the right form, which is y equals something. To graph something, you always have it in the form y equals. So why don't we subtract 2x from both sides? So we have negative y is greater than or equal to negative 2x plus 3. Does everybody understand that I put it in mx plus b form? Now what would we do to get y alone? Divide by negative 1. Did we just divide by a negative 1 onto both sides of the equation? So what do we have to remember to do?
Change the direction.
Change the direction of the inequality. So we should have y is less than or equal to positive 2x. Look, guys, negative 2 divided by negative 1 is positive 2. Positive 3 divided by negative 1 is negative 3. So then we could graph the line, would be negative 3, right, up 2 over 1, right? Everybody? And wouldn't it be a solid line? Right? So it'd be a solid line. I'm not drawing it perfect because we're trying to hurry. And it's y values less than that. Think about it, guys. Y values less than that. Wouldn't that be all of these? Below. Okay, awesome. Not above that line. Okay, we won't do that one. Okay, next one. Graph the inequality. So we have y values greater than the absolute value of x minus 3 plus 1. Will we be graphing a line in this one?
No.
No, this is an absolute value graph, right? But it works the same way. So we're going to graph the function, but it's not a line, it's an absolute value graph. So isn't it right 3, graphing an absolute value function, right 3 up 1? Are we all comfortable with that? Yes? Right 3 up 1. And then it's a sharp V with a slope of 1. So 1 over 1, up 1 over 1. Now is it going to include that absolute value line?
No.
No, it's not included. So now we draw that in, our sharp V with a slope of 1. I'm just eyeballing it here. Okay, so we've drawn in our sharp V. Now we're shading for y values greater than the absolute value function. Aren't these the y values that are larger than the absolute value function? Okay, awesome. Does everybody see what we're doing here? Do we need anything else, or are you feeling okay? Feeling good? You don't need this one? You're sure? You'd be able to get it in y equals form correctly. I think you need this one. What would we do? Divide both sides by negative 2. Did we just divide by a negative? So do we need to change the inequality? Yes. Y values greater than or equal to. You can't divide something that's in here with something that's not in the thing. So isn't this the same thing as negative 1/2 times the absolute value of x minus 4? Isn't dividing by 2 the same thing as multiplying by negative 1/2? Yeah? And then isn't negative 8 divided by negative 2 positive 4? Okay, so then we would graph it by going right 4, up 4, right 4, up 4, and then our slope is negative 1/2. So it's a V. See, that means down 1 over 2. So down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. So down 1 over 2, down 1 over 2. Does it include the line?
Yes.
Yes. So we would draw in a solid line. And then it says y value is greater than. Wouldn't that be above? So we would shade this. Okay, comfortable with that?
Just wondering, why wouldn't you times the -4 by -1?
We did. We just put it in front because you can't divide -4 by -1/2 because it's trapped in the absolute value function. So we still left it times divided by -2, but that's the same thing as multiplying by -1/2. Isn't one like everybody? This is a good question. If we have 2 times 2 divided by 2 is 1, right? Isn't that the same thing if we took 2 times by 1/2?
Yeah, I am.
Okay, you do get that. So we did keep both of them divided by -2. But you can't divide something that's in a absolute value function with something that's not. Does that make sense? Then it would be -1/4, right? Does that make sense? Okay. Awesome. Good questions, guys. Great questions. Okay. So, what if we were going to go backwards? Okay, so this is the last 2 things, then the rest of the time's yours. I don't want to, like, while we're here, we might as well just go, because I don't want to interrupt you. Write the equation of the inequality. So, we have to be able to go backwards. So, first of all, we're going to be doing y values greater than, not including, right? Of this function. Y values greater than this function, because it's shaded above, not including the line. And then, we've got to write an equation for the line. It's an absolute value function, right? So the parent function of an absolute value function is the absolute value of x, but this is shifted. Didn't we go right for up 1? Guys? So then it would be the absolute value of x minus 4, right? Opposite of left and right. And then up 1, so that'd be plus 1. Then you look at your slope. Isn't it up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1? So 1, we wouldn't write it. So this would be going backwards. Y value is greater than the absolute value of x minus 4 plus 1. So you'll be able to go backwards? And then, what about this one? Oh, I didn't shade it. Let's go like this. If this was shaded right here, this whole region, then we would write, okay, the equation of the line, so it's y values, and it's below, right? Less than, and including, because it's a solid line, and then it's a line, so it crosses at 3, right? So we're going to have a plus 3, and then our slope is the rise over the run, so we're going up 1, 2, 3 over 1, 2. Does everybody see that? Of 1, 2, 3 over 1, 2. So isn't that 3 halves x, rise over run? Are we all comfortable with that? We are done. Okay, awesome. So these are the problems you're doing. You're not doing the whole worksheet. You're only doing these problems. So you'll do 1 through 8, 10 through 16, 17 through 26. A lot of them are really quick. There's some graphing paper I suggest you use right here. Ready, set, go.